Hello, everyone. How's it going? Before I start, I gotta make sure Doha, Anna, hello, Reem, Minna. Yes, I know Hanin, of course, she's my student. Noor, welcome. Nadine, thank you so much for being, guys, thank you so much for being here on time, right? So, okay, let's do the spotlight right here. And before I start, uh, Yahya, you're here. Sharon, hello. Ali, you cannot hear me? Okay. Do you guys hear me? Do you guys hear me? Okay. All right. So people said they can hear me, and of course you do see me on the screen, right? Awesome. Thank you, Cameron. So let's get started. Today's topic is important and exciting. Oh, it was your headphone. Good, Ali. Okay. All right, let's start the broadcast. So, this is the third session. And again, just to remind you, this session is for people who are going to start next year. They're going to sit for their exam, for their board exam next year. So, not this year, because if you're sitting this year, then you should be doing something completely different, right? You should be solving past papers and stuff. So, today's topic pretty important, and all chemistry is based on this topic, right? Very important. So we're going to talk about the atomic structure. Now, this is the third session, as I said. So if you did not, I mean, most of you were here last time and the time before, so that's amazing. But just in case you were not here last time or the time before, you can go to YouTube and you can watch session number 1, in which we talked about states of matter, and you can watch session number 2 using this QR code, or you can text me on my phone number and I can send you the links, or you can just go to my YouTube's channel, right? Okay. So, you guys recognize these items? What are these items? And most of them are at home, right? I picked stuff that it's home, right? That it's, yeah, you can find it. 3 of them are metals, by the way. These are metals. This is a non-metal. So, this first one, this orange one, you changed my whole perspective on chemistry. Oh, Yahya, you are so sweet. Yahya Abdurrahman, yes, that's you. Oh my God. All right, wonderful to see you here. Thank you so much, Anna, Ivan. That's right. Yeah, thank you, Hannah. Okay, so this is basically a copper wire, right? This is a copper electric wire. This is something we have in our kitchen. It's called aluminum food container. This is basically made of aluminum. This is an iron chain. And this is a diamond. Do you guys know what diamond is made from? What diamond is made from? Cameron, diamond does not conduct electricity. Everything else, yes. Ivan, thank you. Mazen, thank you. Maria, thank you. Mariam, thank you. Um, team office hours. Is that Dina? Raise your hand so I can put you in the panelist group. And just to let you guys know, we have 4 amazing assistants today. All right. We have Miss Dina. Her name on the panelist group is Click Courses, but this is Miss Dina, my wonderful assistant since 2019, I think. My wonderful assistant Minna, she is also in the panelist. Jenna, another wonderful assistant, and Miss Saba. Guys, I just want to let you know those 4 are the best chemistry assistant in the world. Okay. Minna and Jenna can answer any chemistry question. Miss Saba and Miss Dina can answer any administrative question, you know? So make sure to take advantage of their presence. They are amazing. Okay, Julia, Anna, wonderful. Thank you so much. That is correct. What this is made from is actually diamond is actually made from carbon. Oof, I was gonna say copper. Carbon. It's made from carbon. Okay. So I have a question for you. What is something in common in these 4 things? Copper, which has a symbol of Cu, aluminium, Al, iron, Fe, and carbon. What is, excellent, Abdurrahman. Cameron, excellent. Iyad, yes. Maria, Hamad Samir, awesome. They're all solids, okay. They're all metals, not all of them. Diamond is not a metal, okay. They're all elements, yes, Mark, thank you. What else is in common between these four? What is in common between these four? All what, Ali? What is this word? They all have atoms. Yes. They can all produce heat. They can produce heat. What do you mean they can produce heat? If you burn them, yeah, if you burn them, it's very hard to burn diamond, by the way. Very, very hard. They're hard to compress. Of course, they're all solids. Thank you. Okay, so it looks like some people have watched my first session. All simple covalent bonds. No, only carbon is a simple covalent bond. Transition metals only. Iron and copper are transition metals. Aluminium and carbon are not transition metals. They all have fixed shape. Thank you, Arij. All right, so basically, what is in common between these four, all of them contain tiny, tiny particles. And these tiny particles, scientists call them atoms. Tiny particles, they're called atoms. All right? Not molecules, Mohammed Samir. Not everything is made of molecules. Not everything is made of molecules. All right? So for example, these three metals are not made of molecules, basically. But all those four things are made of tiny small particles called atoms. You cannot see them with your eye. Question: what is the difference when they're all made of tiny particles called atoms? All of them are made of atoms. We're going to see today that atoms are made of subatomic particles called protons, neutrons, and electrons. So they're all made of the same thing. What could be the difference? What is the difference that made copper looks like this, aluminium look like this, iron look like this, and carbon looks like this? What is the difference in the structure? What is it? Structure properties are different. Yes. Excellent, Abdurrahman, you got it. Yes, Abdurrahman got it. Chemical properties, okay. Physical properties. Okay, awesome. Thank you. Bond, amount of, yes, that's right. Their properties, yes, different number of, safe, yes, three types of particles, different, Ivan. Thank you. Yep. Okay, you guys got it right. Okay, half of you got it right. Half of you got it right. Now we're gonna talk about those differences in another slide. But for now, we know that all those four are made up of the same thing. They're all made of atoms. Now, scientists, like long time ago, like maybe 200 years ago, scientists came, Mr. Dalton came and he said, you know, these tiny, tiny particles that we cannot see with our eyes, we cannot see under a regular microscope, they are basically a sphere. They are all made of a ball, a solid ball like a sphere. And in these four things, we have those balls arranged next to each other. And then came along, hello, Miriam. Last time we learned about pressure next. I was surprised. I was very ready to this lesson. I got 2 marks for my, and oh, good, full credit. Thank you, Miriam. That's amazing. So Dalton said, it's just a sphere. All right. So Abdurrahman Dalton said, he said that atoms are just a sphere. And then came Thomson. And Thomson said, you know, Dalton, you are kind of right and you're kind of wrong. You're right that they are spheres. Okay, so we're going to draw a sphere. But you are wrong, because this sphere is not just a neutral substance. It actually has charged particles. Do you guys know what is a charged particle? Thank you, Mark. Yes, that's right. You guys know what is a charged particle? A charged particle. So Thomson said, there's charged particles here. Yes, positive and negative. Okay, why did scientists say positive and negative? They had to just come up with a word, right? So you guys know from physics what electricity is? In physics, what's electricity? Whatever makes my monitor work, whatever makes my laptop work, whatever makes my phone work, whatever makes the light work. What is electricity? Movement of excellent. Thank you, Arij and Safe. Thank you very much. It's movement, and Ivan, thank you. Movement of negative particles. We call them electrons, right? So Thomson came and said, it's not just a sphere. This sphere is positively charged. Okay, big positive here. This sphere is a ball of positive charge. And there are negative, small, tiny, lighter, way light, 2,000 times lighter particles that are scattered everywhere inside of this positive particle. Okay, so that's what Thomson said. And therefore, overall, he said, overall, the sphere is neutral. Why? Because the positive and the negative neutralize each other. They are equal in charge. And so those tiny electrons that are scattered in this ball are neutralizing the positive charge of the atom. So that's what Thomson said. But then came another scientist with his team, and his name was Rutherford. Now, Rutherford is very famous, all right? So Rutherford came and said, you guys are kind of right, and you guys are kind of wrong. You are right that there are charged particles. There are positive charge and there's negative charge. Exactly, Cameron, thank you very much. He did an experiment called the gold foil experiment, and I actually have a representation of it, but that's going to be in another class. And he discovered that actually this positive charge is not the whole sphere. This positive charge occupies a tiny space of the atom, tiny, so small, in the center of the atom, and the rest of the atom is basically empty. So he came in and said the atom is mostly empty. There's a center that's heavy and that's positively charged, and he gave it a name. What is that name? What is that name? Okay, so the center is protons. It's all protons, and he called it the nucleus. Nucleus is usually a term for something in the center. You guys know in biology there's the cell, and then there's the nucleus of the cell, and the nucleus is kind of in the middle, right? Okay, so Rutherford said, you know, this positive charge that you, Thomson, talked about is not the whole thing. It's in the center, and it takes a tiny space of the atom, and the rest of the atom is essentially empty, and the rest of the atom is where those negative electrons exist. So all those negative electrons are around, and they are negative, and they are attracted by that positive, and they are around the nucleus and moving around the nucleus. All right, so positive in the center, negative around it, and the negative is so tiny and so light and so small that it's essentially empty. So he said we have large empty space. And then came Bohr. Now Bohr said, can you guess what he said? You guys are kind of right, and you guys are kind of wrong. All right, so he said, you guys are right because yes, the nucleus is the positive and the electrons are revolving around, and it's mostly empty space, and it's negatively charged around the nucleus. Not yet, that's the next story, next slide, and Dream, same thing. However, those electrons are not randomly, scattered around the nucleus. They actually revolve in certain distances from the nucleus. And he said that some electrons are close to the nucleus. Some electrons are a little further. They're not random. Some electrons are a little further. And some electrons are even further. And some electrons are even further, and so on and so on and so on. I think we don't need it past the first three. Yes, Ivan. Okay. And so he said these electrons revolve in something called energy shells. Energy shells, meaning that these electrons are not in random spaces. They have certain distances from the nucleus, and the reason is they have certain amount of energy, which we will study about in the A-levels. Does any of you want to do all the way until A-level chemistry? So in A-level chemistry, we're going to study deeply about this. All right, wonderful. KTM Iyad. Oh, that's Iyad. Okay. Just curious if Cameron said yes. Awesome. Mu'ayaz says hi. Doha says maybe. Wonderful. Sharon says yes. Wonderful. Mazen, yes. Nadine, maybe. Awesome. Yes. Good. So in A-level, we will talk about those energy levels, and we will talk about the fact that electrons that are close to the nucleus have less energy. Those that are further from the nucleus have more energy. Okay, so Bohr said, it's not random. We actually have energy shells. We have energy shells. So far, we are introduced to two subatomic particles in the atom. The first one is called, these are the positive particles, and they are in the center, they are in the nucleus, and scientists call them protons. Protons. And these are heavy, and they are in the tiny center. And there are light, very, very light particles that revolve around the nucleus, and they are called, and they are negatively charged, and they are called electrons. And the positive is equal to the negative, so they neutralize each other, and the whole atom is neutral. Just like what Dalton said, we have a sphere that's neutral. So this is a sphere that's neutral, but now we know the structure of the sphere. It's not just a sphere, it's not just a ball. It's a center that's heavy, that's positive, and then the most of the atom is just empty space, and it has the electrons revolving around it, and those electrons are not revolving randomly, they're revolving in energy shells. So kind of like orbitals. Think of it like the solar system. The sun in the middle, and then you have a planet that's closer, very close to the sun, and then a planet that's a little further from the sun, and then planets that are even further from the sun, and so on. Judy says, I cannot see the screen. If you are on the phone, Judy, swipe right or left until you see my screen. I believe that everybody sees my screen. I think so, because I have a device and I can see my screen. Yeah, Muhammad, Samir, and Doha, they see my screen. Okay, Judy? All right. Okay. Thank you, team office hours. Is that Omar? I don't know. If that's Omar, thank you for being here. Oh yeah, that's Omar. Oh my God, Omar is here. Omar Walid is here. Guys, I mean, you have the best amazing team here on the, you don't understand this, Maiz. Okay, what is it that you don't understand, Maiz? There's one more, Kate Iyad. That's Iyad. No, there will be another. Yeah, so Miss Saba already answered. So, Maiz, what is it that you don't understand? And which part do you want me to repeat? I can't see the screen at all. Swipe right or left if you're on the phone. No, Jenna? No? Okay, Jenna Abdelati, no. Okay, the electrons in the atom. Okay, Maria? Muaz. Okay, Muaz says he does not understand the electrons in the atom. So, Muaz, basically what scientists found is that atom is not just a sphere. The atom has subatomic particles, and these subatomic particles are opposite in charge. We have the positive part in the nucleus. We have the negative particles around the nucleus. They call the positive part, Muaz, protons. They call the negative part electrons. Do you understand so far? What is on the screen now? Is that the nucleus? This is the nucleus, and these are the electrons. So, Muaz, do you understand now? All right. Now, came another scientist. Okay, thank you, Muaz. His name is Chadwick. And he said, guys, there's a big problem. There's a big, and Muaz and everyone, guys, if you have any questions, please put it on the chat. Miss Jenna will answer you on the chat, okay? If you have any questions, put it on the chat. Not the chat, I mean. You can put it on the chat. Miss Minna will answer you. If you put it in the Q&A, Miss Jenna will answer you. Okay? Okay. All right. In the Q, yes. So, Omar, actually, I just want to let you know Miss Jenna is answering. You just came now, Hala? Hala, you missed 19 minutes of my class? Never do this again. You should join on time, right? Okay. So Miriam, yes, Miriam, that is correct. And that's the topic for another lesson. So Chadwick came and he said, guys, there's a big problem with the structure of the atom right now. What do you guys think the big problem is? Ivan, yes. So yeah, Chadwick came along. Thank you, Ivan. I love it. Chadwick came along and he said, you guys are kind of right and you guys are kind of wrong. So what's the real big problem in this structure? So everybody so far, all scientists said, okay, the nucleus is protons. We may have 2 protons. Maybe we have 11 protons for sodium. Maybe we have 12 protons for magnesium and so on. Chadwick said that's a big problem. If we have 12 protons in the nucleus, or even 2 protons in the nucleus, that's going to cause a big problem. What is it? Protons will repel each other. Thank you, Anas. Excellent. Protons will repel each other. They have the same charge. They are going to push themselves away from each other. Okay? So that was a big problem. So Chadwick said, you guys are kind of right, but there's something wrong. You cannot have all the protons in the center. They're going to repel each other. And so we must have, let me copy paste this. We must have, let me remove this. We must have some neutral particles in the middle in the nucleus, so that kind of like a glue to all the positive particles, kind of like a glue to all those positive particles, so that they can keep all the positive particles together. And these particles were neutral in charge. They did not have any charge. This is smaller, I'm sorry. Let's make it actually a good size here. All of them have the same size, same mass. We're going to talk about that. Okay, so because they are neutral, we called them, thank you, Hannah, thank you, Minna, thank you, Mariam, thank you, Erij, thank you, Hannah, thank you, Safe, exactly. We called them neutrons. All right, so far, scientists found that the atom is not just an atom. It's not just a particle. It's not just a sphere. It actually contains three different things, three different subatomic particles inside it. And these subatomic particles are kind of different from each other. Those three are what? So now, let's talk about the atomic structure. How many of you like this AI-generated image? It's an excited atom. Aha, you like it? Okay, good. Last year, now, when I created this, like, when AI was just out, it was horrible. AI has improved tremendously. Yeah, it's kind of cute, right? Okay, so let's talk about subatomic particles. So, what are those subatomic particles? We found three sub means inside, right? Under subatomic particles. So the particles inside the atom. Judy, that's funny. And what are those subatomic particles? Thank you, Arjun. Thank you, Sarah. Thank you, Muhammad al-Bagir. Muhammad al-Bagir is here. Oh my God. Is that Muhammad al-Bagir? Is that you? Oh my God, you are here. I love you. Oh my God. Okay, so these are protons, neutrons. You're his sister. Oh my God. Thank you for being here. Oh my God. I love Muhammad. I love all your brothers. I taught three of her brothers, and they are amazing. Okay, thank you, Dima. That's right. They are protons, neutrons, and electrons. Now, they differ in certain feature. What is one feature that we discussed so far? What is one feature that differs those three that we discussed so far? Hannah is Jenna's sister? Oh, yeah. The charge! Exactly. Thank you, Mohammed Samir. Thank you, Saif. Tia, Iyad, thank you very much. The features that we discussed so far are the charge. Okay, the charge. And then there's another feature that also is different from those three, and that's the mass and then the location. Let's talk about the charge. What is the charge of the protons? We already talked about this. What is the charge of the protons? Excellent. Thank you. It's positive. Neutrons? No charge. Neutral. Excellent. Electrons? Thank you, Doha. Negatively charged. Thank you very much. Okay, so that's the first difference between the three. What about mass? What about mass? How's the mass different? Does anyone know? I did not teach this yet. So yes, the mass is different. Scientists found that the nucleus is heavy compared to electrons. Now, I mean, heavy compared to electrons, but the reality is the mass of one proton is so tiny. You cannot measure it on a scale in the lab. You just cannot. It's like 0.00000000000000000000000000001 milligram. It is so tiny. All right. So we cannot measure it in terms of kilograms or milligrams or even nanograms. We cannot do that. And so we gave it another unit. We just gave it a number, and we said it's going to be 1 atomic mass unit. Atomic mass unit, which is AMU. Atomic mass unit, which is AMU. So scientists found that protons and neutrons are equal. Now, I'm going to say they are approximately equal because in the A level, I will teach you that there's a small difference, but they are, for now, just consider them to be equal. Protons have 1 unit. Each proton is considered 1 atomic mass unit. Neutrons are also 1 atomic mass unit. What about electrons? Oh, my goodness, they are so light. They're so light, you need almost 2,000 electrons to make up 1 proton. That's how tiny and light electrons are. They are 1 divided by 1,840. And that's why I wrote the word negligible here. Negligible means almost 0. It is so tiny and so small. All right, now what about 1 divided by 2,000 is fine, Duha, okay? What about the location? These subatomic particles are not just swimming randomly in the atom, right? We just learned, based on Rutherford's finding, that these particles, these subatomic particles, live in certain places. Where do protons live? Or where are they? Thank you, Sama. In the nucleus. Thank you very much. What about neutrons? In the cell? No, Abdurrahman, in the nucleus, okay? Neutrons are also in the nucleus. What about electrons? What about electrons? They're not in the nucleus. They are around the nucleus. And I just said a few minutes ago, just imagine the atom like the solar system. The nucleus is in the middle, and then the electrons are revolving in certain energy levels around the nucleus. They are kind of imaginary lines. So this is the nucleus with protons and neutrons. I've represented protons with the letter P. I have represented neutrons with the letter N. And these energy shells are revolving. Now, these are imaginary lines. Do you guys see a line on which the Earth is revolving? No. We just know where it is based on our, experiments and stuff, based on our observation. So we have observed that certain electrons revolve in this space. Some other electrons revolve in this space. Some other electrons revolve in this space. That's Bohr's findings. He said, guys, electrons are not just random. Yeah, they are outside the nucleus, and they are moving, but they're not random. They are specific in certain places. They are moving, but in certain places. They're not just random. I have a question for you that usually students get wrong. Okay, let's see what this group will say. Okay, what is the charge of the nucleus? Is it positive, negative, or neutral? Just put on the chat plus, minus, or 0. What is, half of you got it wrong. I'm going to repeat the question. And guys, just to let you know, half of you got it wrong. What is the charge of the nucleus? Iyad, you got it wrong, sorry. Okay. Mariam got it wrong. Like, I think half of you got it wrong. Okay, overall. Okay, let me repeat. What is the overall charge of the nucleus? What does the nucleus have? It has protons that are positive, right? Protons are positive. It has neutrons that are neutral, no charge. So the overall, okay, so the overall question, does the positive cancel the neutral? Do positive charged particles cancel neutral particles? And the answer is no. Positive particles can cancel what? Negative. You get it now? Okay. So, Kareem, Miss, I did. Oh, okay. So, everyone, half of you got this wrong. The nucleus is positive, guys. The nucleus is positive. It has positive things and neutral things, and therefore, overall, it's positive. Positive how much? Just curious. Do you guys know positive how much? Thank you, Iyad, for the spamming. Positive 3, because I have 3 positive particles. The 0 don't count. Like, we don't count the zeros, right? Okay. My next question. I drew 3 energy shells. Okay. Now, the reality is we found atoms that have all the way up to 7 energy shells. Yes, there is Kahoot. There is Kahoot today. Okay. 7 energy shells. And by the way, this question is in Kahoot. What is the charge of the nucleus? Just to let you know. And I put only 20 seconds per question in the Kahoot. All right. Okay. So scientists found 118 elements. Some of them only have one shell. Some of them, hello, Rathan. Some of them have two shells. Some of them have three shells occupied with electrons. Some of them have four shells occupied with electrons. Some of them have seven shells occupied with electrons. So far we found atoms that have seven shells. Okay. Question: which shell will occupy more electrons? Shell 3 or shell 1? 1 or 3? Which shell will occupy more electrons? Okay, 3 of you got it wrong. Everyone else got it right. Okay, for the people who got it wrong, the 3 people who got it wrong, do you think the closer shell will occupy more electrons, or the wider, further shell will occupy more electrons? If it's further, it will occupy more electrons because it's wider, it's bigger. You guys studied the solar system? Did you guys know that the closest planet, which is Mercury, takes like only 88 days to revolve around the sun, right? What about Pluto? Now, Pluto is not a planet, but when I was a child, it was a planet. But anyhow, topic for another lesson. Pluto takes how many days to revolve around the sun? A lot. A few years to revolve around the sun, right? Why? Because it's so far. It takes so long. This orbit is so big. So the third orbit is so big, it can occupy lots of electrons. Okay, now in school, you did study how many electrons can occupy the first shell, how many electrons can occupy the second shell, and you probably did not study about the third shell because that's where you actually, yes, I can read this, Hala. Hala, just to let you know, Miss Minna, my amazing, wonderful assistant, is here. Guys, we have 7 assistants. Like, we have Miss Dina, we have Minna, we have Jana, we have Miss Saba, and Mr. Omar. Like, we have an amazing team to answer all questions if you have any, okay? Pluto takes 248 years. Oh my God, that's a lot. Thank you for this information. Who said that? Was it Iyad? Yes, thank you, Iyad. Okay? All right, so those of you who studied this in school, how many electrons can occupy the first shell? It is a lot, Nadine. I agree. How many electrons can occupy the first shell? Thank you so much. The whole chat is like 2, 2, 2, 2, 2. Thank you so much. That is indeed the correct answer. Okay. How many electrons can occupy the second shell? How many electrons can occupy the second shell? Okay, the chat is spammed with the number 8. Few people said 4. No, it's 8. The second shell is bigger and can occupy more electrons, and the second shell can occupy 8 electrons. 8 electrons. All right, third shell. How many electrons can occupy the third shell? A lot of people said 8 because that's what schools teach. Now, in the A level, I will teach you that it's actually not 8. The third shell is bigger and can occupy. Miss Hala, Miss Jenna will answer your question. Okay, Miss Jenna, can you please answer Hala's? She has a long paragraph in the Q&A section. So Miss Jenna will take care of it. Thank you, Hala, for your. I love participation, Hala. Thank you. Okay, so the third shell actually, Maria, what is the truth? Maria, what's the truth? Maria says, but in Edexcel, it's 8. Yes, I know that schools teach 8. Edexcel, AQA, Cambridge, they all teach 8. What is the truth? The truth is 18. Okay, so the further you go, yeah, I will teach this in the A level. I will explain this in the A level. I promise, Maria. Okay, for now, don't worry about the third shell. It's not really important for now. For now, guys. Okay, for now. All right. So Iyad, yes, I talk about this in details. Yes, Jana Il Sharif. Okay. So Hamza, yes, Hamza says, is there a way to work it out? Yes, there is. There is a formula to work it out. You guys want to know the formula, or you just care about the exam? Or the current, like the next year exam. Yeah, Arish, thank you. So there is a formula, and it says 2n square, and n is the number of shell. Number of shell. So if you think about shell number 2, it's 2 times 2 square. You don't have to know the formula for your exam, guys. You do not have to know the formula. Relax. Chill, everyone. Okay. All right. Now, if you want to represent the electrons, just like I represent protons and just like I represented neutrons, how do you represent electrons? You can represent it anyhow, like anyway. Very bad at formulas. Oh, Neda, you don't have to. Iyad is asking how old I am. I'm going to talk about this at the end of the lesson. So you can represent, thank you, Cameron, exactly. You can represent electrons either by, oh, Iyad, you are so sweet. I love you. Either by a dot or by a cross like this, or just E minus, or just minus, by a negative signs, exactly, Dima. You can represent it any way you want. I like the dot and the cross, and we're gonna need the dot and the cross a lot next year, okay? Or a circle, thank you, Hannah, exactly right, okay? And the other thing is, so we said that the first shell occupies 2 electrons. So we are going to draw 2 electrons. Here's 1, here's 2, okay? The second shell occupies 8 electrons. I like to draw them in pairs. Because if you draw the 8 electrons like this, 1, 2, 3, 4, 5, 6, 7, 8, it's not wrong, guys. It is not wrong. But is it easy to count? If the examiner is looking at this, is it easy for them to count? They're like 1, 2, 3, right? It's harder to count. So I like representing in pairs. And so if you want to draw 8 electrons, have them in pairs. So here's 1, 2, 3, 4, 5, 6, 7, 8, and that's easier to represent. So far, so good, everyone. Is the structure of the atom clear? Do we have any questions about the structure of the atom? Very quick recap. Atom is a spherical ball, but it's not exactly a spherical ball. It has a center, which has protons and neutrons. We just call them protons and neutrons. Protons are positively charged particles. Neutrons are not charged, and they exist together in the nucleus, okay? And we can have more than one proton. We can have more than one neutron. We're going to talk about this. And then electrons, which are so tiny. Yes, Anna, we are going to have Kahoot. Electrons that are so tiny revolve around the nucleus. Very high speed. They revolve around the nucleus, and every atom will have a different number of electrons. The first shell closest to the nucleus only has 2 electrons. The second shell, a little further from the nucleus, can hold all the way up till 8. Can you have only 1? Yes. Can you have 2? Yes. Can you have 3? Yes. But you can have all the way until 8. Third shell, which is even further, can hold even more. Now, there is a scientific name. There's a scientific name for particles in the nucleus. Particles in the nucleus. There is a scientific name for particles in the nucleus. What is that scientific name? Particles inside the nucleus, which are basically protons and neutrons. Excellent, Arij. Subatoms, not just that. There's Iyad. Okay, thank you, Iyad, for saying this. Guys, Iyad said cell. Guys, what is a cell? Do you guys know? Because that's a completely different topic. But just to make sure you guys understand what we're talking about, we were talking about the smallest thing ever. You know what a cell has? The cell has trillions of atoms. Do you know that, Iyad? The cell has a nucleus and has a membrane, and the membrane has like stuff in it, and those stuff. Iyad, I love those emojis. But do you guys now understand? One cell has a couple of billion atoms, different atoms, okay? So Hamza, great point. Hamza says, what's the point of having something neutral? So those neutrons, they're like the glue of the nucleus. They hold the nucleus together, Hamza. Without neutrons, the nucleus will not exist. It will repel each other. It makes it stable. Thank you, Arij. Okay? All right. So particles in the nucleus are called, now they are in the nucleus. Oh, you were joking, Ian. All right. So particles in the nucleus, now they are in the nucleus. What do you mean, Doha? They are called nucleons. Nucleons. All right. Okay. So far, so good, everyone. Guys, if you have questions, please type it in the chat or the Q&A. We have amazing team here and they are answering pretty fast. I mean, look at this. Jenna answered 42 questions. That's amazing. And Minna answered gazillion questions too on the chat. So thank you so much. All right. Yes, Doha. Okay, so Doha is asking, what are molecules? So molecules is when you have more than one atom together, joined together. Okay, we're going to talk about that next year. Okay, all right. So you guys know how many different atoms did scientists discover? Sanam, no. Yes, guys, thank you very much. Scientists discovered 118 different types of atoms. Okay, now it of course happened over the years, right? When I was your age, I think there was only 111 atoms, and then over the years we've discovered more and more and more types of atoms. Scientists, especially a brilliant scientist called Mendeleev. Mendeleev is like, oh, 118 elements, we've got to arrange them, we've got to put it in a table or something. So he took all those 118, thank you, Sanam, 118 elements or different types of atoms, and he put it in a table in a very brilliant way. We're going to talk about this in another session, but it was so brilliant because the way he arranged it was just amazing. But I have a question for you. Do you think, Lisa, I love you. Oh my God. Oh, thank you so much for the comment. Okay, so do you think those scientists, especially Mendeleev, because he is brilliant, okay, do you think he arranged the periodic table in order of electrons or in order of protons or in order of neutrons? Which one? Which one? So he arranged the periodic table in order of, thank you so much. Most people know, just one person said electrons, which is wrong. Mass number wrong. It's protons. He ordered everything in the periodic table in order of protons. Okay. Now, why do you think he arranged everything in order of protons and not electrons and not neutrons? Why? Increasing number of protons. Yes. Why? Why protons? Why protons? So the reason we selected protons is that protons identify the atom. It identifies the atom. Okay, Khalid, that is correct. Next year we will learn cases in which the protons are not equal to electrons, but right now we're talking about the atom in which protons are equal to electrons. Next year, you will learn that sometimes, yes, exactly, Muhammad al-Bagir. What's your name? Muhammad's sister. I think your mom told me before. Oh, thank you. I did it a while back, but I don't remember. I think he's answering. He's talking to Cameron. Are you talking to Minna? I think you are. Okay. So protons, the number of protons identifies the element. It's like the finger. Guys, you know, thank you, Cameron, for letting me know. Oh, Lena, okay. You guys know each of you have a very different fingerprint. My fingerprint is different than Cameron's fingerprint is different than Lana's fingerprint is different than Khalid's fingerprint is different than Amna's fingerprint, right? We all have very, very unique and different fingerprints. Each atom is also unique. It has also its own fingerprint. Even twins. Yes, thank you, Omar. Exactly. And that's why each atom has a different number of protons. And the number of protons is what identifies the element. And so I have a picture of a fingerprint so you guys never, ever, ever forget this concept. Okay? And that's why the proton number, we have another name for it. The proton number, we have another name for it. Does anyone know? Oh, Neda. Does anyone know? Aha! Proton number has another name or another term, and that other term is atomic number. Atomic number. Okay? You guys remember my question at the very start of the session? When I said, what is in common between these four? And we all said, oh, they are all made of atoms. And all atoms are made of protons, neutrons, and electrons. Now you guys answer me. What's the difference between these four things? What's the difference between these four things? And this is copper, too thick. This is copper. This is aluminium. This is carbon. Oops. This is carbon. It's diamond, but diamond is made of carbon. And this is iron. Excellent, Dima. Excellent, Timo. Excellent, Muhammad Samir. Jana. The other Muhammad. Marwan, no, not that's not what I'm talking about today. Exactly, Abdurrahman. Hannah. Yeah. What do you mean? Okay, so they're all made of tiny particles. All of them are made of atoms, okay? The only difference between these atoms is the number of protons. The fingerprint, guys, the fingerprint. Okay, I have a question in the Kahoot about this fingerprint. What identifies an atom? Okay? I'm learning a lot. Do you hold these meetings out of love? Oh, Sanam, you're so sweet. Sanam, I'll give you my phone number at the end if you want to chat, okay? So copper, the only difference between these four is the number of protons. You're going to find that the number of protons are different. If you have an atom with 29 protons, then it's copper, and it cannot be anything other than copper. If you have an atom with 13 protons, then it's aluminium, and it cannot be anything but aluminium. If you have an atom with 26 protons, then it's iron. If you have an atom with 6 protons, then it's carbon. Easy, guys? Easy? Okay. Yes, Maria, we can. Yes, there is something called isotopes. But if there are 6 protons, we call it carbon. Yes, we can have an isotope of carbon, but it's also 6 protons. Okay, Muhammad? Samir? All right. And so, Mendeleev, our amazing genius, he put everything in a periodic table. Now, the periodic table is on the internet, and you can find a lot of periodic tables out there. They're very, very similar, but they all have all the elements arranged in order of protons. Thank you. Exactly. Thank you very much. Now, I have some good news for you, guys, okay? But let's take a look here first. So notice that. Here's the atomic number. It's the smaller number. Here's 1. Here's 2 after it. And then here's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way until the biggest element, which is 118. All right? Now, here's the good news. The periodic table is given to you on the exam. How is that? You do not, absolutely do not. Oh, Jana, wonderful. You absolutely do not have to memorize anything. I just want you to be familiar and be able to decode the periodic table and understand all the information on the periodic table. Because there are 4 pieces of information given to you on the periodic table. This is a part of the periodic table. Okay, this is a part of the periodic table. Yes, Ivan, on the exams, you will be given a copy of the periodic table, right? So I also get it. Yeah. So this is lithium. Okay, it's one of the elements, one of the 118 elements that we have discovered so far. And any element on the periodic table, you will be given 4 pieces of information: a smaller number, a bigger number, a name, and a symbol. Okay, guys, the smaller number is basically the proton number. Now, sometimes the smaller number is at the top, and sometimes the smaller number is at the bottom of the element. Does not matter. The smaller number is the proton number, which we also call atomic number. Okay, now each element, as I just discussed, each element has a very unique number of protons. If it's 3 protons, it's lithium. If it's 11 protons, it's sodium. If it's 12 protons, it's magnesium. Why? Because it is the fingerprint. Now, on the exam, guys, do not write fingerprint. Just write it identifies the element. Okay? All right. The second piece of information I'm going to talk about the third piece of information. The third piece of information is the name. Okay, it is the name. Now, metal. Now you will notice something about the name. A lot of them end in IUM. Yum, lithium, magnesium, sodium, potassium, uranium. Right. So a lot of them will end in IUM. Metals usually, now some metals like iron and copper do not end in yum, but metals usually end in yum. Okay. Now I have a funny story here. I have a funny story. Guys, notice on the periodic table that some names are based on places or people. Places or people. So Tennessee is based on the state Tennessee, the United States. I live in the state of Wyoming, very unknown state. There's another state called Tennessee in America. Yeah, California. Let me show you California. Based on California, the state California. Okay, there's no Wyomingium, my state. Yes, Anna. All right, so some names are based on the state. Some names are based on the country. Americanium, where is it? Here, Americium. Yeah, if I discover something, I'm gonna call it Wyomingium. How is that? A Wyomingium. There's Francium. I think it's based on France. All right. And some of them are based on people. Neptunium and, oh, this is Europeum, based on the continent Europe. Where's Einstein? Here. Einsteinium. Einsteinium. Okay, so guys, when I was your age, when I took my IGCSE, you will not believe what year I took my IGCSE. You will not believe it. It was in 1999. Okay, yes. That's how old I am. Yes, Rutherford. Where's Rutherford? Rutherford. Yes, there's Rutherfordium. Okay, based on our amazing scientist Rutherford, right? Yes, Judy. So when I studied chemistry, I studied with the best chemistry teacher in Dubai. I was born and raised in Dubai, and then I moved to America. His name was Dr. Sajan, and he told me a story. He said, Nirvana, if you discover an element, you can call it your name. So I was like, sounds good. Nirvanium. That's interesting. And then my younger sister said, her name was Lubna, and she's a scientist in the University of Illinois, Chicago. She's doing like cancer research and really amazing stuff. And she said, I'm going to discover element number, I think we were at 113. And she said, I'm going to discover element 114, and I'm going to call it lubnanium. So, guys, guess what? If you discover element number 119 or 120 or something, you can call it your name. Yes, you can. Amnanium, Marianium, Judinia, anything. You can call it your name. Okay, so if you discover it, you can Nadinium. Yes. Okay. The third piece of information. So lithium, magnesium, sodium, barium, copper, iron, a lot of names, and some names are pretty long, so we had to give it a nickname. How many of you have a nickname? I have a nickname and I'm not sharing it. How many? Adenium. That's interesting, Adam. Yeah, Iyad, you have a Doha. You have a nickname. A lot of nicknames, yeah. What is your nickname? Come on, share it. Cameron's nickname is Cam. Thank you for sharing. You have 5 nicknames. Oh my god. Lizanium. Oh, Lisa says, I'm gonna create Lizanium. Mimo. Okay, Mariam's nickname is Mimo. Doha is Zoha. Okay, I have multiple ones. All right, so guys, on the exam, please do not write nickname. We have a more professional term for the nicknames of elements. Hamuz. Oh, Hamza's nickname is Hamuz. Mimi for Mariam. So, just like Mariuma, exactly, just like how we have nicknames at home and our loved ones call us by our nickname. My kids sometimes they call me by my nickname. Ayuda. Elements also have a nickname. Now, the professional term for that is symbol. Thank you very much to Anna. Atomic symbol. So it's kind of like the nickname, all right? And it's either one letter. Yes, Ed, I am. It's either one letter or 2 letters. Now, First class in English, when I was in first grade, they taught us how to write words, how to write proper names, and how to write sentences. What is a rule in English? The first letter has to be, thank you very much, Muhammad Al-Bagir. Thank you very much. Anas, thank you. Yeah, thank you. Yes, exactly. The first letter, it's gotta be uppercase letter or capital letter. In America, we call it uppercase letter, okay? And the next letter should be a small letter, okay? So examples are cobalt. C is uppercase, the C is capital, O is small. Nickel, N is capital, I is small. Easy? All right, now we have something crazy going on. You will find some symbols not match the name. I mean, cobalt, CO, nickel, Ni, copper, CO, magnesium, Mg, chromium, Cr, manganese, Mn. Makes sense, right? What else? What else makes sense? Sulfur, S, chlorine, Cl, bromine, Br, iodine, I. It makes sense, right? However, bad news, some symbols do not make sense to us. And the reason is differences in language. Not all scientists were English. Some scientists spoke other languages. And so there was an element called natrium. This is basically sodium. And so that's why, thank you very much, Qusay, Greek, exactly. That's why sodium's symbol is not SO, it's Na, natrium for sodium. Now, guys, yes, the periodic table is given to you on the exam, but I cannot imagine you searching for sodium in the periodic table because you don't know it's Na. Now, I had a student come to me and she was like, Miss, lead is not in the periodic table. We have a wrong periodic table. They forgot to put lead. And guess what she was looking for? She was looking for anything that started with L. She was looking for a symbol that started with L. However, lead does not start with L. It's Pb. Does not make sense at all. Okay, another one that doesn't make sense. Antimony, Sb. Tin, Sn. Now the ones I really want you to know are sodium, Na, potassium, K. Potassium actually stands for kalium. Those of you who are going to go to medical school or pharmacy school, you're going to learn about kalium a lot. There's actually a condition, a disease called hyperkalemia, meaning a lot of potassium in your blood, or hypokalemia, meaning a lot, little potassium in your blood. And both are dangerous. They can affect your heart. Okay, guys, I'm a pharmacist. You guys know that, right? Okay, so that's important. Sodium and kalium, or sodium and potassium, are important. Iron is also important, and it came from ferrum, and this is also important. Silver is kind of important. I'm gonna have a yellow star here. Gold is also kind of important, but doesn't appear in the exam a lot. Okay? Yes, Tia. Mercury is Hg. Tin is Sn. Okay? So guys, just so you don't keep looking in the periodic table, where's potassium? It's K, okay? So I want you to be familiar with some of those symbols or nicknames. All right, so that's the third piece of information. The fourth piece of information is the big number. This big number, which can be at the bottom of the symbol or at the top. Doesn't matter. It's the bigger number. And this bigger number is called the mass number. And it's the mass of the atom. Guys, what is the mass of the atom? What is the mass of the atom? And it's on the Kahoot, by the way. It's one of the questions on the Kahoot. So the mass number is what plus what plus what plus what? What? Electrons. Timo, do electrons have any mass? Do electrons have any mass? Thank you, Mohammed Samir. Oh, Lisa, thank you. Do electrons have any mass? No, almost no. You need 2,000 electrons to make up one proton. So we're not going to count electrons. Electrons do not count, guys. You're not counting electrons. What are you counting? What are you counting? Aha! You're counting protons and neutrons only. So the mass number is the nucleon number. We talked about that before in a previous slide. It's the nucleon number. And it's the proton plus the neutron together. Okay, now we have a cute term for it, and it's called relative atomic mass. It's the atomic mass, and it has a symbol, a nickname. It's called AR, the atomic mass AR. Oh, Lena, I have that in a slide, Lena. Okay? All right. So, guys, now that we talked about those pieces, 4 pieces of information in your periodic table, you can calculate, you can find out a 5th piece of information. Can you guys guess? What is the 5th piece? Maria, that's the molecular mass, the mass of the molecule, which is more than one atom, okay? Yeah, you guys are smart. So we have the smaller number, which is the proton number, represented by P. We have the bigger number, which is the mass number, represented by P and N. You have P plus N together, and we have P alone. What can you calculate from these 2 information? What can you calculate? Excellent. You can find the neutron number, right? You have the mass number, you have the proton number. If you subtract them, you're going to find the neutron number, right? Because the mass number is what? P plus N. Proton number is what? P. If you subtract them, you get neutron number. Easy? Okay, let's have a little bit of an exercise. Let's have an exercise. This is fluorine. This is fluorine. This is the small number, right? This is the small number, which is what? What is this small number? What is this small number, Cameron? Protons, thank you. The small number, Cameron, is the protons, thank you. Or the atomic number, thank you. What about the big number? What about the big number? It's the mass number, thank you very much, which is protons plus neutrons, right? Okay, how can you calculate the neutrons? How can you calculate the neutrons? Tell me the neutrons. What is it? Excellent, Erij, Musa, Brine. Thank you. It's 19 minus 9, which is 10. Excellent. Okay, let's do another one. What is the small number? Which is 15. 15 is the what? Thank you, Doha. The proton number. So proton numbers are 15. The big number is, the big number is the mass number, which is protons plus neutrons, and therefore neutrons are 31 minus 15, which is 16. Thank you very much. So we have 16 neutrons. Okay. Small number here is the protons. Big number here is the mass, which is protons plus neutrons. What are the number of neutrons? Excellent, Timo. Excellent, Mohammed. Excellent, Maria, Arij, Doha, Nada, Iyad, Khalid. Thank you very much. It is 23 minus 11, which is 12. Iyad. Iyad, why did you find it to be 11? Is it 11? What's 23 minus 11? Guys, it's 12. Yes, who wrote 11? You confused me. Oh, you're saying the number of top. Okay. All right. Big number, proton. Sorry, this is the small number. Did I say big here? Yeah, small number. Okay. So the small number here is the proton. The big number here is the mass number, which is protons plus neutrons. What are the number of neutrons? Excellent, Maria. 39 minus 19, which is, thank you very much, 20. Our amazing copper, used everywhere. Small number, 29. That's the protons. Big number, mass number, which is protons plus neutrons. Neutron number, excellent, Malak, excellent, Arij, Muhammad al-Bakir, Timo, Iyad. 64 minus 29, which is... What is 64 minus 29? 33? Do we really need a calculator for this one? What is the correct number? 35? 35. Okay. Yes, 35. Thank you. 35. All right. We have one more example, and then we're going to do Kahoot. All right. Okay. Small number, protons, which is 26. Big number, mass number, which is protons plus neutrons. Neutron number, 56 minus 26, which is, thank you so very much. Thank you, Dima, Cameron, awesome, Maya, yeah, 30. Thank you, Dana. Wonderful. You guys ready for Kahoot? You guys ready for Kahoot? Okay, before we go to Kahoot, just a quick reminder that I'm the author of The Joy of Chemistry, which you can get for free today, only today, from Amazon. It is available. The digital copy is available for free, which is a colored copy. You can also text me, and if you text me, I'm going to give you my notes also for free. I want to give it to everyone in the world. I want everyone to study from my notes. I promise you, it's the best notes out there. Also, this is my phone number, Miriam. This is the link, and I'm gonna, Miriam, if you want to text me, I can send you these notes. This is my phone number on the WhatsApp. And I also have, and I also promise you, this is the best summer you will find ever. Thank you, Maria. Maria, just text me. Do you have my phone number? This is my phone number, Maria. Miss Saba can also put on the chat my phone number. Oh, thank you, Miss Saba. She is reading my mind. My goodness. Okay, guys, I have summarized Cambridge, Edexcel, AQA, GCSE, and AQA Trilogy in 12. Oh, yes, Omar, thank you. In 12 pages. I promise I promise, not because I did it, I made it because it's really, really good. I've had people who texted me saying these summaries are the best. If you want these summaries, and I'm giving it away for free, if you want it, just text me on my phone number and I'm gonna give it to you. All right, you guys are ready for Kahoot, right? Okay. One more thing. The next free session is on the 23rd, and we are also going to have a free session August 14, and this is going to be the start of a new course. Okay, this is going to be the start of a new course. And dun dun dun, Kahoot. Let's get started. Live game. What is it about? Kahoot is about today's lesson. Noha, just text me. Do you have my phone number? Malak, Miss, can we leave before? Malak, it's up to you. It's fun. It's fun. Don't leave before Kahoot. Okay. You go to kahoot.it. You go to kahoot.it, Amna, and you put this pin number 6007644. Miss Saba have put it in the chat. Miss Jenna is typing it on the Q&A. You have no, yeah, you guys can go to kahoot.it and put this code. Awesome. We have 40 people joining. Awesome. Anas is saying that my team are legends. I agree. This team is amazing. Amazing. Jana, Omar, Minna, Saba, Dina, like, oh my God. Karim, I cannot leave the screen now. Go to amazon.uk and type my name. You're gonna find it. Or type The Joy of Chemistry. Oh, Neda, thank you. Yes, Neda says it's an amazing team. Or Iyad, what are you then? Okay, you guys ready? 65 people are here. Oh, you still have 2 years to go? But you're doing great, Iyad. You're doing great. Okay. He's in year 7 and he is learning beautifully. And guys, just to let you know, yes, Mohammed al-Bakr, that's right, you are also in year 7. My GCSEs are this time next year. Yes, Cameron, you are ready to go. Wait, Miss, do not start. Come on, Amna, join. Okay. Hala is also in year 7. Nice. May, what is the name? Name of what? Pre-IJD, but that's good. Kindle. Yeah. Okay. All right. Are you guys ready to start? Okay, let's get started. Does anyone need a minute? One more minute? How do I get the free PDF of The Joy of Chemistry? Go to Amazon.uk. It's free today. Amazon allows me 5 free days a year. Miss Year 7 or grade 7? Not exactly, Dana. Yeah, kind of, yeah. You can think of it that way, yeah. Adam, come on! Amna, come on! Guys! Okay, we have 71 people joined. Awesome. Why Judy? The internet is bad. Oh yeah, if the internet is bad, it's gonna be a bit hard. Um, okay. It's not working for some reason. Judy, just go to a browser. Or you guys know you can download the app. My book, The Joy of Chemistry, is free today. The hard copy, I think it's like $6, $7 on Amazon. I don't know. Amazon sells it. I just put it up there. The other thing, May, is if you're a GCSE student or an IGCSE student, you can text me and I'm gonna give you the notes for free. Okay? All right. You guys ready to start? You guys ready to start? Let's get started. We have 72 people. All right. The code is gonna still be there, and you will still be able to join even if we are inside the game. Okay? All right. Let's get started. How do I get the soft copy? Omar, are you talking about my notes? Just text me. I'll give it to you. PDF. All right. Electrons carry what charge? Duh. And the pin number is at the bottom if you want to join. Okay? Seven seconds. 4, 3, 2, 1. And yes, of course, electrons are negatively charged, right? Okay. Mohammed Samir, Mazen, Abdurrahman, Amr, Iyad, and Yusuf. Good job. I mean, good job, everyone, not just those 5, right? Yes, Amna, that's fine. You can answer on the chat. You put neutral? Oh my God, Cameron. Okay. Neutrons have no charge. True or false? Of course, it's true. Yes, neutrons are neutral. Oh, the chart is completely different now. We have Mazen on the top, Abdurrahman Amr, Mohammed Samir, Huda, and Kareem. All right, thank you, Amna. Yes, it is true. What charge does the nucleus carry? Nucleus. Nucleus. You guys have only 20 seconds. 4, 3, 2. Yes, the nucleus is positive. Reaction speed to click it ASAP. Video games are good for you. Oh yeah, my son would do this very quickly. All right, fourth question. What particles are found inside the nucleus? Particles inside the nucleus. Particles inside the nucleus. 9 seconds. So you guys a lot of you got it wrong. It's nucleons, not just protons. Protons and neutrons, and they're called nucleons. Okay, you clicked by mistake. Okay, focus, Abdurrahman. Thank you, Amna. Okay. Where are electrons found? Where are electrons found? This is so competitive, Ivan. Well, I mean, it's fun, right? Yes, in shells around the nucleus. Thank you. Awesome. Awesome job. 69 of you got it right. What is the maximum number of electrons in the second shell? In the second shell. Second shell. Second shell, Cameron. Second, 8 only. Third shell is 18. Okay. All right. Seventh question, 7 out of 10. What does the atomic number represent? Yeah, Cameron, we're learning. That's okay. Totally fine to make mistakes now. We're learning. Okay, atomic number. What does it represent? Atomic number. What does it represent? Atomic number. 2, 1. Protons. Thank you. Why did we have 15 people say protons and neutrons? It's the atomic number, not the mass number. Okay? All right. What identifies an element? What identifies an element? What identifies fingerprint an element? The identity, the fingerprint. 9 seconds. No, Ivan. Just the proton. Just the proton. That's the identity of the element. All right. Yeah, the electrons are equal, but sometimes we change the number of electrons changes. That's the topic of another lesson, right? So yeah, Ivan, I mean, you have a point. Mass number of an atom is the sum of what plus what? Mass number is the sum of what plus what? Mass number. Do electrons count? Yes, protons plus neutrons. Excellent. Okay. Question number 10, and this is the last question. Last question. There's a bonus point here. Which subatomic particle has the mass of approximately 1/1840 of a proton? 1/1840 of a proton. Last question. 6 seconds. 4, 3, 2, 1. And yes, it's electrons. These are the lightest thing. Your internet is bad. Oh, it's okay. All right, guys, look at the podium. And number 3 was safe. Congratulations. And number 2 is Dima. Congratulations. And number 1 is Mohammed Samir. Congratulations, guys. I am proud of all of you. Ivan, you are number 9. Congratulations, guys. I am proud of I think 69 people participated today in this Kahoot. Proud of you all. Thank you so much. I'm going to take a screenshot of this for good memories. Amazing job, everyone. Save to photos. Do we have any questions? I'm gonna have my phone number for you here. Do we have any questions? Amna and Mariam, you have your hand raised. Do you have a question? It is fun, I know. Yeah. Okay. Oh, Ivan, there were 72 people participating. That's amazing. I'm proud of all of you. Ahmed, I see the discussion. Thank you. What's the name of my book? It's called The Joy of Chemistry. This is my book, I think. Yes.
Miss, you said that the nucleus of an atom, it's positively charged. Miss, how does that make sense if it's the same amount of neutrons and the same amount of protons?
What is the charge of neutrons?
They're neutral. They don't have a
They're
charge.
neutral. No charge. Do they affect the charge by any way?
Oh, no, they don't. Okay, I get it. Thank you.
You are welcome. Okay, Mariam Ahmed is asking how I am 43 years old. Okay, I have 3 kids. This is their picture. I don't think you say. Okay, so this is Julia, this is Abraham, and this is Adam. So yes. And I think I live in the coldest place on earth, Wyoming. So cold. I can take courses from next year. Yes, Nada, yes, you can. You are welcome to join Element 119. Yes, Ivan, if we're in Dubai, we can't open it in Amazon. Sarah, text me. I will send you my notes. How about my notes? Much better. Much better. Right? And my summary. So good. Right? Lena, I live in a state called Wyoming in the States, United States. Oh, Mariam, you're so sweet. I love you. I love you. Okay, can I appear in 2026? Doha, yes, if you're in year 10 or 11, yes, you can. All right, Judy, thank you. Uh, First time attending my session. Amna, make sure you go to my YouTube and Amna, thank you so much. I love you. Make sure you go to YouTube and you watch the previous 2 sessions that are available on my YouTube channel. Your year 8, Doha, maybe wait until 10. Thank you so much, ma'am. Oh, yeah, you are welcome. This is the name of my YouTube channel. Dr. Nirvana. Dr. Nirvana, basically. This is, oh, thank you, Minna, for posting the YouTube channel. That's amazing. Okay, so this is the name of the YouTube channel. Do we have any other questions? Can you send me the notes also? Just text me. I will send you the notes. Thank you. Team is brilliant. Yes, the team is brilliant. I know, Mohammed Samir. Thank you. I have the best team in the world. I'm telling you, this is the best team in the. You will not find anyone like Jenna, Minna, and Omar. Nobody are like these 3 people, right? Yeah. And Miss Saba and Miss Dina are the best, like, managing assistants, administrative assistants in the world. Thank you, Nada. Yeah. All right. Thank you, Sharon. Very nice to help you today. If you guys have any questions, please text me. Here's my phone number. I'm gonna let you all go. Here's my phone number if you want to text me. I will see you next Sunday for the 4th and last session. Amna, just text Miss Saba. Miss Saba, Amna wants a certificate for attending today's session. And so yes, please just text Miss Saba. Amazing. So, oh, Cameron, thank you so much. Cameron attended the 3rd time with me today, so thank you so much. Mohammed Samir, thank you. You did it. You did it, and you did wonderful. Thank you so much. Thank you, Maryam. Yes, please attend next time, which is the 4th and last session. Thank you so much, Or, for attending. Love you all. Enjoy your Sunday. Have a wonderful day. I'm gonna post this on YouTube. Thank you so much. Bye.